In this video, we will discuss about many things about epoxy paints, but I would like to start with a brief history about epoxy. Epoxy, also known as epoxy paint, was developed in the 1930 and 1940. Its invention is credited by the Swiss scientist Pierre Castan and the German chemist Paul Schlag, who worked independently to create polymers with high chemical resistance and adhesion. With its introduction in the industry in the 1950s, epoxy revolutionized the world of adhesives and coatings, valued for its durability, corrosion resistance, and insulating properties. Today, it is widely used for various applications, including the automotive, aerospatial, and construction industry. But what is actually epoxy paint? Epoxy paint is a special type of paint made of epoxy prepolymers, which are medium-sized molecules containing a chemical group called epoxide. Under certain conditions, they bond with other molecules called hardeners to form the solid paint film. Now, what components does it contain? Epoxy paint is typically presented in two parts, the part A and the part B. The part A contains the epoxy prepolymers, while the part B contains the hardener. The paint is formed between the reaction of these two substances, which solidifies and dries it, a process known as curing. Ideally, the cured and dried epoxy paint film is composed solely of epoxy prepolymers, solely of cross-linked epoxy prepolymers and hardeners, along with some additional additives that provide some specific desired properties, such as pigments and fillers. However, when referring to the components used to create and apply the paint, solvents and temporary additives should be mentioned. These components don't remain in the paint, they fulfill a specific function and then they evaporate. Solvents provide mobility to the prepolymer and hardener. Once the prepolymers and the hardeners have reacted, the solvent evaporates, ideally assisted by heat. Additives can be temporary or permanent. Permanent ones include pigments and fillers to enhance strength and provide color. Temporary additives may help during application by reducing viscosity, surface tension, etc. Now, what are the uses of epoxy and why should we use it? The primary use of epoxy is to protect the underlying substrate it is applied to, providing mechanical, chemical, and electrochemical protection, another way to say anticorrosive protection. It is used in industries such as petroleum, agro-industries, and mining industries, with expensive machinery subject to harsh environmental and operational conditions. Industrial carbon steel, often used for its physical properties, is reactive and prone to oxidation under environmental conditions. Epoxy paints are an excellent choice for covering and protecting this metal. This paint forms a physical barrier and provides corrosion protection through metallic pigments that sacrifice themselves for the metallic metal. Now, what are the main differences between epoxy and other paints? The main difference between epoxy and other paints is that epoxy is specifically designed to protect the substrate. While other paints are intended for aesthetic finishes, shine, etc., epoxy paint primary function is protection, and its chemical components make it highly resistant in all respects. On a microscopic level, epoxy paint has a dense, compact, and resilient structure compared to other paints on the market. Now, what are the characteristics of a good epoxy? The primary characteristics of a good epoxy are its chemical, corrosive, and mechanical resistance. Chemical resistance means that it is not easily degraded by acids, alkalis, or other substances. Mechanical resistance refers to the paint's ability to withstand stress, impacts, scratches, and abrasion, with fracture resistance being particularly important. This is due to the covalent bonds in its structure, giving it high cross-linkage and resistance to deformation. Epoxy paints are typically harder and less plastic, which is desirable for durability, though some applications benefit from slight plasticity. Now, I would like to discuss a little bit about the chemical explanation behind all of this. The epoxy network is the result of a chemical reaction between the epoxy prepolymers and the hardener. The epoxy prepolymer has an epoxide group on each end, which is geometrically unstable and seeks a more stable condition. The hardener molecule is compatible with the epoxide group, and when they meet with sufficient energy, a reaction occurs, forming a bond. The hardener can create up to 4 bonds with surrounding prepolymer. resulting in a cross-linked macromolecule where the epoxy paint film is a single giant molecule. Now, what is the future of epoxy? Epoxy future will focus on advanced material protection in extreme environments with high fire, corrosion, and abrasion-resistant formulations, ideal for critical infrastructures and industrial applications. Research is ongoing into nanotechnology for antimicrobial and self-healing epoxies, enhancing surface protection for hospitals, potable water systems, and structures exposed to severe weather. Nanoparticles will improve durability and resistance, creating effective barriers against corrosion by reducing oxygen and water particles penetration, which protects metallic surfaces in harsh environments. These nanoparticles also increase hardness and withstand heavy traffic and abrasion. In some cases, provide antimicrobial properties. These advances aim to make epoxy a more efficient and durable protection barrier, ideal for safety and resource conservation applications. Now, painters. When working with epoxy, always wear protective gear, gloves, masks, and goggles to avoid direct skin contact and inhalation of vapors. Work in well-ventilated areas and follow the manufacturer instructions. Thank you so much for watching. This is Cosmos Coatings.